Hi makers! It has certainly been a long time since I uploaded a how-to video to this channel. I have worked for over 3 months on this project, and now I'm going to show you how to replicate it for the fraction of the time it took me and for about $500 US if you already have a regular bike. So in this first video I will show you the first steps of this huge project. Let's get started. So before we get on to building our e-bike, I would like to talk a little bit about why I don't just go and buy one like a normal human being. E-bikes today are still quite expensive and aesthetically not pleasing at all with their bulky, low capacity battery packs. The cheapest e-bikes are more than $100 more expensive than ours, but they have a more than 2 times worse battery capacity. And I also want it to look badass, like my friend's mopeds, but with no emissions. Also, there are links in the video description for all the parts used in this project that I ordered online. Enough with the talking, let's begin. The very first step is to make 3D models. I used Fusion 360 for this. You will be designing this on your own, as it wouldn't help you if I had provided my files, because every bike is different. Measure your bike's frame and design the battery holders and frame mounts. Based on your measurements, design the front and rear light housings with side and rear panels for the front one. We will be putting electronics in here later. I have provided some small parts in a folder in the description below, like turn signal caps and gear mounts. I hope these are helpful for you. You should also design the parts so they in no way should affect the rideability of the bike. I had to redesign the rear light because my legs would rub against it while riding. Proceed with 3D printing all the parts. So for the battery modules, you will need the mains power cable, 6 BMS circuit boards, 12 battery holders. Also a couple of mine were redesigned at some places so they would fit within the frame, and your battery pack. I'll go with this 10S4P pack with 40 of these Panasonic cells, which are the same that are inside Tesla cars, but with a slightly lower battery capacity. These were by far the most expensive part of this project, excluding the bike itself, with a $200 price tag. Anyway, start by splitting the pack into smaller 6S chains. That means that you will end up with 6 modules of 6 batteries arranged in a chain, with 4 to spare. You should be really careful because you do not want to short any of the cells, as I accidentally did sometimes. In some cases, you might need to solder a few cells together to get the desired modules. Solder cables to all the connections and to the 2 ends of the first battery chain. After test fitting the cells into the holders and to the frame mounts, secure the batteries with hot glue. Proceed with connecting the wires to the circuit board's pads. Repeat these steps 5 more times so you have 6 modules in the end. After filing down some surfaces and modifying some prints to fit the frame, with some help I was able to wiggle the modules into each other, sliding them into the mounts. I actually didn't need a drop of glue for this. Next, take a steel plate big enough to cover both sides of the main triangle of the frame and use the scorch and bend technique to make those triangles. Drill holes big enough for screws near the 3 corners of the 2 triangles at the same points. Transfer the markings onto the frame mounts and drill out the holes. After making new holes in the motor's mount, secure it with screws to the bottle cage holes in the down tube. The next step is to make one big hole in each plate for the motor. I mostly used a multi-tool with a circular cutting bit for this. While I was at it, I also painted some details. So now we are going to apply this carbon fiber film onto the side plates, so let's get started with that step. This is mostly protection against rust. When applying a vinyl, it is important to push the bubbles out. I use the credit card to solve this problem. It is also a good idea to use a heat gun when wrapping it around edges. After that, we'll need to apply some silicone around the frame and covering it with baking paper. The reason for this is that we want some sort of water resistance while still being able to remove at least one of the panels after removing the paper. After 24 hours, remove the baking. I regret what I said earlier. Do not use baking paper, at least not this kind. Maybe if I would have used cellophane, it would have been better. Anyway, I went on to securing the charging port in place. Next, I secured 3 buck converter circuits to the non-removable panel with silicone. I adjusted the potentiometers to 1 ampere and 25.2 volts on all of them. After fixing the panel into place, I soldered a female bullet connector to each of the 3 lengths of cable and a male to the 4th cable, and inserted the cables into the charging port, adding some glue. I soldered 6 diodes to all of the positive power pads on the BMS circuits with the white stripe on the circuit side. I connected all the module's input and output grounds in parallel. To all the input ones, I connected the cable with the male bullet connector. I then connected one cable with the female bullet connector to each of the positive input terminals, and all the output ones I connected with the ground line of all the modules, and connected all the output positives in parallel and tested the charging system. But there was nothing to charge at this point, so I went ahead connecting the BMS circuit's positive pads together in parallel. I also soldered cables to all the diodes' other sides without a stripe and connected them in parallel. The diodes are a safety precaution for the charging systems. And please, don't be stupid. Remove the power first. To the line without the stripe, I finally connected the output wire of the converters. Wow, all this connecting gives me a headache. Next, we will start making our charger. You will need to cut 4 lengths of cable with the same length and use electrical tape to bind them together. Then, take your 20 ampere 24 volt power supply and connect 3 wires to the positive terminals and 1 wire to the negative. I previously connected a power cord off camera. Solder a female bullet connector to the cable's other end, which was connected to the negative port, and solder male plugs to all the other. Connect the charging cable to the port. Plug the power cord into the wall, and the lights on the converters should turn red. When they turn blue, the charging is complete. Next, I replaced the old grips with new ones which have a built-in lock and throttle. After letting out some air, I was able to loosen the rear wheel and insert the 3D printed gear mount. After securing it firmly to the spokes with zip ties, I wiggled in the aluminum gear as well and secured it with screws and nuts. I then connected the chain and made a simple, temporary chain guide out of the scrap steel and used epoxy to secure it. I soldered a temporary system switch between the positive battery terminal and the speed controller. I connected the motor, throttle and lock wires to the controller as well and tested the system first without and then with the chain. So now I'm going to test this bike for the first time. I expect to have several problems, mostly with the chain and the gears, but we'll see how it turns out. Now let's go out and test it. So I went out, hopped onto my bike, and the moment I throttled the motor gear and the knot loosened and fell off. So I guess I have to improve this design of the attachment. I have to figure something out. And to see what I came up with and the continuing of this project, you will unfortunately have to wait until next weekend. So thanks for watching this video, I really hope you enjoyed it. Don't forget to like and subscribe for more, and I will see you makers next weekend.